This is Skill Building Workshop Series 7, where we're talking about the Keysight 4024 scope. And this is video number 4. I'm going to walk you through using cursors. And again, all we're going to use in order to illustrate these techniques is the coax cable connecting from the compensation signal at the front of the scope into channel 1. This is available on every scope. And all the principles that we're talking about with the 4024 apply to really all scopes. Well, the first step in using this scope is setting up the signal so we can see it on the front screen. Regardless of what else you want to do, if you can't see the signal on the front screen, the scope isn't going to know what to do with it. So here we have we're going to apply rule number 9, which is anticipate what you expect to see. We're looking at the signal from the comp source on the scope. It's about 1 kilohertz and it's about 2.5 volts. What we see on the screen, and you'll notice that here's the scope, and I can point to the various positions, and to see the screen in close-up, I've got it projected over here on the side. So everything that we see on the scope here is actually in more detail over on the right-hand side. Well, the first thing we're going to do is, hey, let's get the signal on scale, and that's with the vertical controls. We're going to decrease the scale. Right now it's at, or you can see over here, it's about 50 millivolts per division, so we're going to crank it down until we see something that is on screen. And there we go. So we're at 1 volt per division, and we see the signal on screen. Second is, I know it's 1 kilohertz. That means it's on for half a millisecond and off for half a millisecond. The scale is 20 milliseconds, so we're going to have to zoom in a little bit. Paying attention to the features of the scope and how it is set up is part of what I call situational awareness. Really, really important. You want to optimize the settings of the scope in order to reveal the kind of information you care about. So we're going to zoom in to see that signal that's repetitive. And there it is. Well, unfortunately, it's moving all around, and of course that's because of the trigger. And so we're going to make sure we're triggering on channel 1. So here is let's turn on the trigger button. We get the contextual menu down here changing. We're triggering on the edge. Source is channel 1, rising slope, but we still don't see a good trigger, and that's because the trigger level is off. So here's the trigger knob. We turn it on. Oh, the trigger is set for way down here. We want to trigger closer to where the signal is. Now, we can move it up manually, and sure enough, we move it up there and it's triggering. Great. Here's another trick. And we saw before that, if you're offset and you want to move 0 to the center, we said, okay, just push the offset button in and it automatically centers. We said, hey, if you're moving the position, you'll notice the little caret over here at the top. As I move the position, that caret moves. That's where the 0 is, t equals 0. If we're off somewhere and we want to move time t equals 0 to the center to see what's happening right at the beginning, again, we push that button in, automatically centers. And likewise, if our trigger level is way off and it's just not triggering, and I don't even know where the trigger level is because it's off screen, if we push the trigger button in, it automatically moves the trigger level toward the middle of the signal if it can figure it out. And so we're triggering now, which is great. We're still on auto, which is perfectly fine. And you can see at the very top here, we're on auto. Here's the trigger voltage level, channel 1, rising edge, and it's triggering here. So everything's working great, and we can expand out, and now we can see that signal on whatever base we want. So we've got our signal centered. Every signal we're looking at, the whole idea of using the scope is to measure waveforms on the front screen and extract useful information. Right now, I'm taking about 2,000 different measurements in this buffer window. My time base here, we can read the time base up here. It's a millisecond per division. There are 10 horizontal divisions, so that's 10 milliseconds worth of data. In that 10 milliseconds worth of data, I'm taking about 2,000 individual measurements. That's a huge number of data points. I don't know what to do with 2,000 data points. Instead, I want to convert all of that data, all those measurements, into a few useful terms. We call those terms figures of merit. The figures of merit characterize the signal that we're looking at. And so here's a square wave. What are the figures of merit? Well, one of them is the period, how often it repeats. 1 over the period is the frequency. Another is the peak-to-peak value. What's the voltage range for that signal? Another one might be the rise time. So every signal has some figures of merit. And the very first thing that we want to do after we set up the scope is we want to read those figures of merit from the scope screen. Always, before you use cursors, which we're going to demonstrate here, or before you use measurement tools, always use your Mark I eyeballs in order to read the figures of merit from the front screen to get a rough estimate of what they are. Because if you can't read them on the front screen, how do you expect the scope to measure them? So the very first step is adjust the controls to get those figures of merit off the front screen. Well, let's see. One of those figures of merit is going to be the peak-to-peak voltage. And I can look at that screen and I can see, okay, here's 0 down here because I've pushed the offset button in, so 0 is in the center. And I can read where's the peak. Oh, here's 2 volts, here's 3 volts, about 2.5 volts. So I can read right off the front screen, about 2.5 volt peak-to-peak. The second term I care about is the period. What is the time for repeating? Now, here is one cycle, goes up and repeats again, and that's 1 division, roughly. And I can use that, or if I want to get a little better, more accurate value for the period is, I'm going to zoom out a little bit. And now I can read that period a little bit more carefully. Because now here it starts and it goes down and up. Here's another cycle. In fact, here's another cycle. There's 2 cycles. I get 2 cycles in. Let's see, how much time is this? This is half a millisecond per division. So it's 1, 2, 3, 4. So that's 2 milliseconds. And it looks like maybe 0.1. So it's about 2.1 milliseconds. I get 2 cycles. So it's a little bit more than 1 millisecond as the period. If it was 1 millisecond, if that's the period, 1 over that's the frequency, which is 1 kilohertz, about what I expected to see. So I have a rough idea of what the peak-to-peak value is and what the period is right off the front screen, just my Mark I eyeball. You always want to adjust the settings on the screen of the scope in order to be able to make it easy for you to extract those figures of merit you care about. That's why you have to have an idea of what question are you trying to answer with the scope measurement. To get a little better, more accurate value off the front screen of those values, we can use cursors. And over on the, we talked about the horizontal controls, we talked about the vertical controls, we talked about the trigger. Just to the right of the trigger are the measurement features, the cursors and the measurements. I'm going to turn the cursors off. And over here next to the screen on the right-hand side, we have some menu items. Now remember, the first thing that we want to do, if we want to, and it's contextual, we can change what appears over here, you see over here. We're going to push the menu button in, and here are the different things that we can display on the right-hand side. The summary is one of the most important things. That's going to tell us what the acquisition rate of the scope is. It says here's the bandwidth of the scope, 200 megahertz. And here next to it is the acquisition rate. We're taking data at 313 megasamples per second. If we change the time base, that changes the number, the acquisition time, and for a fixed number of sample points, that changes the sample rate. Not too critical right now. We'll deal with that a little bit later. But it also, more importantly, tells us for each of the channels, they're color-coded here, for each of the channels, it also tells us what the attenuation setting is for the scope. And for channel 1, it's a 1-to-1, which is perfect because that, after all, is what I've got connected in. Always check that to confirm. If you have a 10x probe, you're going to want to see 10-to-1 over here. If it's a 1x a cable, such as we have here, you want to see a 1-to-1. That means that the tip voltage that we measure over here is what is displayed on the screen with no scaling. Next, if we pull down the menu, the next item we have are the cursors. So let's turn that on, and now it's the same as activating the cursor button over here. Now we have the cursor menu. And again, the menus are contextual. If you look down here at the soft buttons, you can see here, we can access the cursors. The first menu item, the source, tells us which channel do we want to apply the cursor measurements to. Well, we only have channel 1 on, so we're going to keep it 1, but we could use others as well. So we're going to use channel 1, and now we can select what cursor do we want to turn on. We're just going to turn on one of them. So we have two X's and we have two Y's. X, of course, is in this direction, Y is the vertical direction. Let's turn on one of the cursors, the X cursor. And now we can control the position of that X cursor and read it right off the screen over here. We can control it by moving it with our finger. So I'm just grabbing the X mark and I'm moving my finger. Now the other thing that we want to control is the units. The X units are seconds. We want the units for the X cursor to tell us that instantaneous time at which the cursor is located. The 0 is in the center here, and the position of the cursor, now that we've got it set for the second scale, the position of the cursor is telling us what that time instant is given the scale. I can move that cursor with my finger, and let's see. So I can see here that the 0 is where we're starting, that's where we're triggering, that's time t equals 0. And I can go to 1 division, and here is 1 division. And that 1 division, it's a little bit more than a millisecond, just as we suspected. And if I go to 2 cycles, that's about, slightly more than 2 mils, about 2.1 milliseconds. Now I can move it with my finger, or I can use the knob. When the cursor button is highlighted, I just change the knob and I can move it around. So that's how we can get the X position. I can turn on a second cursor to access the menu item at the bottom I want. I push the cursor button in, I access a second cursor, and I turn on the second cursor, and now I have two cursors. There's one of them, and now if I move the knob, you can see the second one hiding out. In addition to identifying the position of the second one as I move it around, you can see the second one here, I can also get the difference. It's x2 minus x1. So since x1 is 0 in this particular case, I move it around over to here, and here is that difference, which is the roughly 2.1 about 2.1 milliseconds. And conveniently, one of the assumptions is, okay, you got two of these. One of the things that you might want to do is get the difference, which is a period. What's that in frequency? And so sure enough, here it is. Here's the difference, slightly more than a millisecond for one cycle. And the calculation is done automatically on the front screen, a little bit less than 1 kilohertz. Exactly what we expected to see. So we can move the X and an X1 and an X2 cursor around, read the values off the front screen, and it allows us to get a little bit more accurate value for X position. Likewise, we can do the same thing with Y. I'm going to turn the Y's on, and just because it gets a little cluttered, I'm going to turn the X's off. Depending on your application, you can keep them both on. And now we get the peak to peak. Remember, I eyeballed it as roughly about 2.5 volts. Now let's see if we can get a little bit better value. So here I highlight cursor 1, and now I can move cursor 1, and I'll move that to the bottom here, and I can highlight cursor 2, and now I move cursor 2, and sure enough, it's a little bit under 2 volts, or a little under 2.5 volts, 2.45 volts, the best I can do just with my eyeball. So we have the opportunity of moving the cursors around in the vertical direction and horizontal. We can look at the absolute value, we can look at the differences. So that's one way of reading the values off of the front screen. In the next video, I'm going to show you how we can use the measurement function to extract a few specific figures of merit.